r cap sin theta means n cap cross r. N cap unit vector magnitude 1. So n cap r sin angle sin theta. So it is n cap cross r. But if you say that d omega is a vector which is nothing but n cap into d phi, then our final result we get the change will be nothing but n cap cross r or n cap d phi cross r, which gives you d omega cross r. So angular velocity omega related with this angular velocity, we can omega is the change in angular velocity. Okay, this is the expression. So our change is nothing but d omega cross r. So you can say due to rotational effect we have d omega cross r, g. For g is any vector. If a, d omega cross a. Okay, if force, then d omega cross force. Momentum, d momentum is equal to d omega cross momentum. Okay, any vector. So our general expression became dg space is equal to dg body plus d omega cross g. If you take its time variation, we can say rate of change of any vector is equal to rate of change of vector in the body plus omega cross g. Omega is the angular velocity of the rotating body. So, okay, omega dt d omega. This is the general formula. So we are here inside earth is this one. So whatever we observation occur in earth is not equal to actual space. This space minus omega cross g. Clear? Hello? Hello? Is it clear?
Hello? G means
G is any vector. G is, we take any vector. G for any vector. Okay, we can write this formula like this. Okay, space, this is r for rotating, omega this. If you write a here, we write everywhere a. Okay, if you write v here, v. Force, a, write a velocity, you write v everywhere. Okay. G is any vector. So this relation. So then come to the Coriolis effect. Okay, this equation 5 is basically the kinematic law upon which the dynamical equation of motion for a rigid body are founded. It also may be used to describe the motion of a particle relative to a rotating coordinate system. So equation 5 provides the needed modification of the equation of motion relative to the non-inertial system fixed in the rotating earth. So non-inertial, which is actually changing with time, it is applicable to that omega cross r. Okay, we see this. Consider the radius vector r from the origin of the earth system, earth to a given particle. If r be the position vector of any particle from the origin of the earth, you can say, okay. And then using that formula, we can write d by dt of r space is equal to d by dt of r rotating plus omega cross r. In place of g, I take r. Okay. So this implies dr by dt is velocity. V in space is equal to Vr plus omega cross r. Now again we take V as the g. If we take Vs, particularly Vs as the g, then my formula will be dVs by dTs is equal to dVs by dtr plus omega cross Vs. Now in place of Vs, put this Vr plus omega cross r. But dVs by dt in S system is d square rs by dt, which is acceleration. So left hand side is acceleration is s, and right hand side in place of Vs put this Vr plus omega cross r because it is in r frame. So Vr plus omega cross r. Since r frame, so dVr by dt in r frame means d square r by dt in r frame, which is ar. So first term will be ar, second term derivative of omega cross r. Here omega cross a cross b means omega cross Vr plus omega cross r. So this one ar plus omega is the angular velocity. If we take the angular velocity is fixed. Generally for angular velocity of earth is fixed. Earth is rotating a particular value of angular velocity. So in that case we can keep omega as a constant. So derivative will taken with only r, dr by dt, which is Vr. So here omega cross Vr means 2 omega cross Vr plus omega cross r. Okay. Now, if we multiply the mass of the system, we get the equation of motion F is equal to ma. So F here mas. This F is actually measured in space. Normal case, normal mechanics case is MAR rotating and 2 MVA plus R plus M omega omega plus R. But for rotating, when we are in a rotating system, for us actually force just like M into AR. So M into AR is not equal to F exactly. It is F minus 2 terms, 2 M omega cross VR, M omega cross R. Okay. So to an observer in the rotating system, it therefore appears if the particle is moving under the influence of effective force. So for a rotating body, it's the force. An observer in the rotating frame, this is the force. Actual static force, or what we observe from force, from Newton's mechanics, minus 2m omega cross Vr minus omega cross R. And the second term actually depends on velocity. If velocity of the particle is 0, then this term will 0, which is actually Coriolis effect, or you can say that is Coriolis force, which depends on velocity. So the event which have velocity, which is changing with time, that are affected by the Coriolis effect. Okay. And this term is nothing but, if you see, its magnitude will be m omega square r sin theta, which is familiar centrifugal force. mv square by r magnitude is centrifugal force. But the second term, which is for a particle in stationary, then that term does not give any contribution. But if particle is moving, not stationary, then it is effective. That is known as Coriolis effect, and the term is Coriolis force. So F Coriolis is nothing but minus 2m omega cross Vr, or you can, observing minus, you can write A cross B is equal to minus B cross A, 2m Vr cross omega. This Coriolis force is velocity dependent force arising from Earth's rotation. Clear? Hello? Hello? Hello?
Yes, sir.
Is it clear? So this is the Coriolis system. How to remember? So if you see for Earth, actually for Earth omega, if you calculate this 7.29 to 5 second inverse, because 2 pi coming to its original position, it takes 2 pi angle radian, and time is 24 hour around that, 24 into 36 100 seconds, and this is actually sidereal year, solar year 365.5, and if you made from other star, if you measure the solar year, actually let's change it a correction factor, very small factor, but actually normally we can calculate from this 2 pi by 24 into 3600, this value will be this omega, velocity of the Earth. Okay, that is the correction now. So due to Coriolis effect, freely falling particle will affected. If you see, this direction is 2 omega cross B, always it affected towards right. Okay. Since particle is almost vertical, north-south flow, the deflecting force is in the east-west direction. That means in the northern hemisphere, like India, here people, or all the effects are actually move towards east. They slightly move towards east. Whatever calculation done by our Newtonian mechanics or normal formula, if you exactly measure, then you found all are slightly shifted towards east due to this Coriolis effect in northern hemisphere. In southern hemisphere, it will be opposite, move towards west. Okay. This is the Coriolis deflection. So in northern hemisphere, the Coriolis effect deflect a projectile. If you are also a projectile air surface, right its direction of travel. Right means it's the Coriolis deflection is opposite in southern hemisphere. These are the main effects. They affect the direction of role, oceanographic, meteorological case, cyclone or other cases. These are the written applications. Okay. So this effect is this much 2m omega cross v. Okay. Then we go for the next part, dynamics part. And start with rigid body dynamics. Rigid body equation of motion. Okay. Dynamics means here we discuss angular momentum and kinetic energy about motion about a point. We generally know the formula angular momentum and kinetic energy, but here we apply for a rotating frame. Suppose here we take two particles R1 and R2 with the position vector with respect to arbitrary origin O, and difference between them is R. Then by formula you can say R2 is equal to R1 plus R. R2 is the vector R1 plus R. So if we take its derivative, dR2 is equal to dR1 by dt plus dr by dt. Okay. But dr by dt in S, you already saw in the last class, last slide, it is omega 1 plus R. Omega 1, that quantity. So now using this, we actually here it proved that omega is constant, not necessary. So angular velocity generally for a rotating body, when you apply this Coriolis effect, other things, we keep it constant. Omega 1 is called omega 2 means angular velocity is constant. Now comes to the angular momentum. Linear momentum is equal to P mv. You know P is equal to mv. And angular momentum L is equal to R cross P. L is equal to R cross P. So we can write R cross mv. But if there are large enough number of particles in a system, we can take the sum of angular momentum of each particle. So L is basically sum of Li summed over I Li, and Li is nothing but R cross Pi. R cross Pi is Mi Vi, so we can write summed over I Mi R cross Vi. But Vi is dri by dt. But dri by dt S, we know the formula. And dri by dt S is equal to dri by dt R plus omega cross Ri. Okay. Again dri by Vi is equal to omega cross Ri. We put here Vi is equal to omega cross Ri. So our formula will be L Mi Ri cross omega I. Vi in place of Vi, I write omega cross Ri. Why dri by dt is 0? Because we know in a rigid body, we are applying, assuming that at a rigid body, the distance between any 2 points is fixed. So dri by dt, Ri is fixed. Dri by dt is equal to 0. So Vi, dri here, Vi is equal to omega cross Ri. Okay. So in place of Vi, I put omega cross Ri. So now A cross B cross C. So that A cross B cross C is equal to B A dot C minus C A dot B. Back minus cap a formula. So B A dot C minus C A dot B. Ri dot Ri is equal to Ri square. Again Ri dot omega means X omega X, Y omega Y, Z omega Z. So now R is position vector, xi cap, yj cap, zk cap, omega is omega X, omega Y, omega Z. So component wise we solve it. So let's say Lx, the x component will be which is multiplied by I cap. That means by this term Ri square omega X. From this term I cap means xi I cap multiplied all these three, which will be obviously xi into xi square omega X minus xi yi omega y, xi zi omega z. Mi is multiplied with each term. So this is my x component of Lx. Similarly in y and z component, so this angular momentum vector, I can say this Lx is c something into omega x, something into omega y, something into omega z. I can write it Ixx into omega x, Ixy omega y plus Ixz omega z. Similarly, I can write Ly and Lz. So now I can say L, which have Lx I cap plus Ly j cap plus Lz cap. Or if you write it component wise Lx, Ly, Lz, it basically a matrix multiplication. Ixx, Ixy, Ixz, Iyx, Iy, Yz, Izx, Izy, Izz into omega x, omega y, omega z. Okay. So L is equal to I omega, I can say. If I write here, L is nothing but I omega. I is actually 3 cross 3 matrix here. Okay. L is equal to I omega. And the x component is Ixx. And that I is nothing but your moment of inertia tensor. It will be a tensor. So we can L is equal to I omega vector. So we don't write vector on I. It is actually a tensor quantity, and whose x Ixx is equal to how much? Comparing this, you can say omega x, omega, sorry, not omega, mi ri square minus xi square. So Ix is mi ri square minus xi square. Ixy minus mi xi yy. It product term means minus and product. Okay. Xy, so product of x minus xi yy into mi. Xz, product of minus mi xi zi. But same term xx, there is an extra term. Xx product is minus xi square, true, but there should be a term like mi ri square minus. Okay, this is a matrix. So general formula you can construct. So if you take it for a continuous body, we know a discrete summation for continuous integration. We replace the summation by integration, and we use the term density. So this equal to rho density mass per volume into r square minus x square dv. If the Ixx component in continuous system, if I R Iyx, Iyz, Izz, Ixz, Ixy, combining all, I write this formula, because when x is equal to y or j is equal to k, only two term exist. Otherwise, this term will be 0, only one term, product term. J is not equal to k, it is minus xj xk. And this mass term contain here mass per volume. Here density means mass per volume. So we convert it to a continuous system, so we divide volume and integrate over dv. So we cancel m and this previous formula, this formula mir square x square. Okay, so now we can write L is equal to I omega. I stand for the moment of inertia operator. Okay, and the inertia tensor and moment of inertia. So in terms of moment of inertia, we can calculate the kinetic energy. Kinetic energy is equal to mv square, or summed over I half mi vi square. But vi square means vi dot vi. Take one vi as omega cross ri. What we found in the past. Yes, I think here vi is equal to omega cross ri. So I am putting this formula omega cross ri and taking the vector identity a dot b cross c is equal to b dot c cross a is equal to c dot a cross b. We found this t is equal to nothing but half m omega cross ri cross v. What this term is L. So we already show that. So it is omega cross L. But again L is equal to I omega. So I can write t is equal to half omega dot I dot omega. I is the moment of inertia tensor. In omega is omega n cap. So I can take n cap omega square taking outside n cap dot I dot n cap. Which is equal to half I omega square. It is scalar I. moment of inertia I is a scalar quantity whose formula is n I n. You converting to the coordinate actually mi r I square minus r I dot n cap square, and known as moment of inertia about an axis of rotation. This is the formula for moment of inertia about axis of rotation. Since L is equal to this, we know this formula. L is equal to I omega, so I can comparing and write I is equal to this. Here you what we got. Okay, this is moment of inertia formula. Here is we know two theorems in moment of inertia. Parallel axis theorem and perpendicular axis theorem, right? So we use parallel axis theorem here. If we know about moment of inertia about a particular axis, then we can calculate the moment of inertia about an axis which is parallel to the previous one by using the formula that moment of inertia about the axis plus mass into square of perpendicular distance between them. This is the formula you know in class 2. Okay, we actually use this formula to calculate different moment of inertia quantity. Next thing is how we calculate the moment of inertia. Suppose we know I is equal to n cap I n cap. N cap is the unit vector along the direction of rotation, axis of rotation. Suppose sometimes n cap is given, let's say alpha I cap, beta j cap, gamma k cap. Then what is the value of I? Take n I n, but I dot n cap is equal to this one. Unit vector, if you take both dot product, you find this one. The formula is I x x alpha square plus I y y beta square plus I z z gamma square plus 2 I x y alpha beta plus 2 I y z beta gamma plus 2 I z x gamma alpha. Okay. Using this, different concepts are used. Okay. There is an important problem which sometimes asks in your examination. Find the moment of inertia of a homogeneous cube of mass m, density rho and side A, assuming the axis lies along the edges with the origin at one corner. So origin is here corner and this is the axis x, y, z. We know the formula, continuous body. The formula ijk is equal to integration of v rho r square del j k minus x I z dv. R square means here x square plus y square plus z square or x1 square plus x2 square plus x3 square, whatever. Now Ixx, according to our formula, I when j and k are same, 1 1 let's say, or xx say, so it will be r square minus x square. R square is x square plus y square plus z square. So r square minus x square is obviously y square plus z square. So I write here y square plus z square. And volume integral along x, integration along x, integration of y, integration of z. Since it is a cube and its length is a, so in every direction it is same. Along x is a, y a, and z a. Okay. So now we can write rho y square plus z square dx dy dz. If you integrate it, and let's say what x is not present here, so separately integrate x, which give you a. Rho is a constant, so rho a. Now integrate y square plus z square dy dz. First integrate with respect to z, then it will be y square z plus z cube. Or first integrate over y. What here? If you integrate over y, it will be y cube by 3 plus z square y. Then again integrate with respect to z dz, so it will be y cube z plus z cube y. Okay. Okay. In place of y, putting a, you can like a qz plus a z cube. But z is also 0 to a. Putting that, we have 2 by 3 a to the power 5. So the I-axis component is rho. If in place of rho, you can also use mass for volume m by a cube, volume of a cube. We get 2 by 3 ma square.
So del J,
Similarly,
what is del J? Del J, what is del J? R square del
Del
J.
Z is the Kronecker delta symbol. It means when J is equal to K, it is 1. When J is not equal to K, it is 0. We call Kronecker delta symbol when it will be 1 for J is equal to K. Okay. When J is equal to K, it is 1, otherwise 0. Okay, you know, I think Class-3 also you know this delta JK, Kronecker delta symbol. When 1 J is equal to K, 1, otherwise 0. Else it is 0. Clear?
Okay, sir.
So only XS component it is non-zero. When I take, so I take R square, it is 1. Let's go to second component XY. XY component, oh, XX is same since the cube, it is XX component same as YY component, ZZ component. Now go to product XY. In XY case, delta JK is equal to 0. So this term vanishes. Only minus rho XJ XK. Okay. Means XY means minus rho XY. Integration of dx dy dz. Similarly, there is no Z, so integrate separately Z. XY integration dx integration gives you x square y, putting a square y, again y doing y square, putting value of a4, again here a, so a5, so minus 1 by 4 a5, converting to mass per unit volume, we found minus 1 by 4 ma square. Since the cube yz component is same as xy, zx xz or are same, so putting off diagonal element as minus 1 by 4 m square and diagonal 2 by 3 m square, we got the inertia matrix. Okay. There are also some problem. N cap is given. You have to find the I dot n using the past formula. This formula you can try to calculate I. Okay. This is all about moment of inertia, and this Q problem is very important. Mostly asked in your examination. Okay. Next, we go for Euler equations and other things. Solving rigid body problem and Euler equations of motion. You know already, if a rotating body, it can have two type of kinetic energy: translational kinetic energy and rotating kinetic energy. Half mv square translational kinetic energy, rotating case moment of inertia waves like mass, and angular velocity omega square, I omega square. Okay, this is the formula. So now also we can say Lagrange. If you follow Lagrangian mechanics, you can say it has a translational part and rotational part. But Lagrangian formulation, okay. So using this, we try to solve many problems here, particularly symmetrical top, which is our syllabus. So to solve the problem of symmetrical top using this Euler's equation. Uh, Kinetic energy or rotational kinetic energy, particularly in terms of component, you can write half I1 omega square plus I2 omega square plus I3 omega 3 square. Okay. Now go to exactly the Euler's equation of motion. For the rotational motion about a fixed point at the center of mass, means if a fixed point is known, even we assume it is center of mass, the direct Newtonian approach leads to a set of equations known as Euler's equation of motion. So instead of using Lagrangian formulation, we use our Newtonian approach for getting the equation of motion for a rigid body, which is first given by Euler, known as Euler's equation of motion. We consider either an inertial frame whose origin is the fixed point of the rigid body or a system of space axis with the origin at the center of mass. That we consider the center of the body set of axis is either center of mass or the given point, fixed point. If a rigid body rotating under the action of a torque, we know torque is equal to dl by dt, change of angular momentum. Okay. So now using the rotating formula, we know dl by dt s is equal to dl by dt v body or rotating plus omega cross L. Now this must be equal to n. So right hand side must be equal to n. So dl by dt plus omega cross L is equal to n. Now we know L is equal to I omega L in terms of component I1 omega 1 I cap, I2 omega 2 j cap, I3 omega 3 k cap. And omega is omega 1 I cap, omega 2 j cap, omega 3 k cap. And so what is the omega cross L? Okay, first calculate dl by dt. L is this, so dl by dt is omega 1 I1 into omega 1 dot I cap plus I2 into omega 2 dot j cap plus I3 into omega 3 dot k cap. Omega is angular velocity is constant, but omega its component may vary. Magnitude of omega is maybe constant, but omega 1 dot, omega 2 dot plus omega 3 dot. So now torque is equal to dl by dt. So in space, or dl by dt space is equal to dl by dt rotating plus omega cross L. We get dl by dt this, and omega cross L, it can be calculated this term in terms of determinant. Using this we found I cap and omega 2 I3 omega 3 minus omega 3 I2, all this you have written like this. Opening the determinant, we found this term. Left hand side we can write n1 I cap plus n2 j cap plus n3 k cap. And so you see there is something into I cap, something into j cap, and something into k cap. If you compare, you write n1 is equal to this. What is multiplied with I cap? N1, this is n1. N1 is equal to I1 omega 1 dot plus omega 2 omega 3 into I3 minus I2. And this is N2, which is multiplied with j cap, and N3 multiplied with k cap. Okay, so N2 is like this, N3 is like this. Combining the, you see, N1 means I1 omega 1 dot plus, here one component is absent, omega 2 omega 3 and I3 minus I2. Okay. Similarly here omega 3 omega 1 I1 minus I3, 1 omega 2 I2 minus I1. Last one is first minus first one. Okay. So general formula will be II d omega I by dt plus jk epsilon ijk omega j omega k ik. Epsilon ijk is known as Levis beta symbol. If you know, if two indices are same, then it will be 0. But if the indices are in the even permutation, cyclic order, that means after x, y, z, or Levis beta symbol, y, z, x, you see Levis beta symbol, Ti, Vi, Ta. This is Levis beta symbol, epsilon ijk. We call it Levis beta symbol. If two indices are same, let's say I is equal to j, then 0, j is equal to k is equal to 0. But if it is even permutation, in order x, one y, one z, cyclic order. Suppose after x, y, then we take z, positive. If y, z, then x. X, y, z, y, z, x, or z, x, y, then it plus 1. Otherwise minus 1. You can check here, suppose I j k omega j into omega k I k. Here I2 j3. Okay. So k will be plus omega k I k. K is 3, so I3 plus. But 2, when for second case, change jk. J is 3, k is 2. Order is opposite. 3, 2 means z, y reverse. So it is minus I2. So this is a general formula and which is known as Euler's equation of motion. Okay, are you getting my point? Hello? So this is actually Levis beta symbol, you know, in mathematical physics. That using this you can find this. So now this equation 5 and 6 can also be derived from Lagrange's equation using Lagrange's formula d by dt del t by del qj dot minus del by del qj is equal to qj. Now important application of this equation is in the case when I1 is equal to I2 is not equal to I3. symmetric. We consider symmetry axis. Okay, symmetry axis is Z, so that I1 is equal to I2. If I1 is equal to I2, then this term will be 0. Other two remain same. Okay. Then equation motion slide change with the case of heavy symmetrical top with 1 point fix. Here actually we take a rigid body with 1 point fix. Fixed point is either center of mass or the given point. And torque free motion of rigid body. Torque free means if n is 0 means it's all component 0, n1 0, n2 0, n3 0. If n1 0, n2 0, n3 0, then what will the equation? So our left hand side will be 0. If this is the 0, you can say what is the case? I1 omega 1 dot is equal to minus of this, so if you observe minus I2 minus I3. This is the case. I1 omega dot this, omega 2 omega 3, I2 minus I3 omega 2 this and omega 3 this. And this equation what implies if n is equal to 0, angular momentum is constant, we know that. Now we can show also kinetic energy is constant. With this, we know n is equal to 0 means n is dl by dt. So dl by dt 0 means L constant, angular momentum constant. Now multiply omega 1 with first equation, omega 2 with second equation, and omega 3 with third equation. So here will be omega 1 multiplied. Multiply omega 2 in the second equation, omega 2 here multiply. And omega 3 in the third equation. Then add. What will the result? Tell me. Hello? Is my slide visible? Hello?
Yes, sir.
Please add. Add left hand side and add right hand side. So what you get actually if you add right hand side? You see omega 1, omega 2, omega 3 in all term. So when I add I2 taking omega 1, omega 2, omega 3 common, I2 minus I3 plus I3 minus I1 plus I1 minus I2. This means what? If you add all this, what is my result? Hello? Please see if add I2 minus I3, see this term. Please add this. I2 minus I3 plus I3 minus I1 plus I1 minus I2. What is my result? Omega 1, omega 2, omega 3 is take common in each term. Taking common I get this. Hello? If you add what is 0. Yes, right hand side is 0. So left hand side is this term I1 omega 1 dot omega 1, I2 omega 2 dot omega 2, I3 omega 3 dot omega 3 is 0. But what is this? If you see the derivative of half I1 omega 1 square plus half omega I2 omega 2 square, I3 omega 3 square, and I omega square means I omega square is nothing but kinetic energy. But derivative of kinetic in 0 means kinetic energy is a constant. Thus, for the torque free motion of a rigid body, angular momentum and kinetic energy are constant of motion. Okay, these are simple analysis, is not needed. Next, we go for very important part is actually heavy symmetrical top, which is in, okay. The heavy symmetrical top. Symmetrical top slide is visible. Hello? 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 Is symmetrical top slide is visible?
Yes, sir.
So actually this is an example. See the picture. What is that? What is it? Have you seen this? Hello? ये पिक्चर देखो ना नहीं এটা কোনটা हेलो
यस सर ଦେଖିଛୁ ପିଲା ବେଳେ ଯାଇ ସହିତ
not too much science top not it is actually example of a symmetrical top the axis is symmetric and it is rotate about its own axis but if you see its motion when you leave actually it attached to a thread when you leave that it will move if you see its motion just like a tilting motion it moves in tilt or moves so there are three kind of motion here observed one is about its own axis another is make a axis and rotate around it this precession okay also sometimes it is a up down motion it not in the floor a slightly take height then motion within this direction so three type of motion observed here for that reason it is very important and it is so symmetrical top an example is type child's top also in different navigation instruments we used this kind of objects. Consider the motion of a symmetrical body in a uniform gravitational field with one point on the symmetry axis is fixed in space. Here you assume one point is fixed. A wide variety of physical systems ranging from tile stop to complicated gyroscopic navigational instruments are approximated such heavy symmetrical top. Both for its practical application and illustration of many techniques previously developed, the motion of heavy symmetrical top deserves a detailed exposition. The symmetry axis is of course one of the principal axes and will be chosen as the z axis of the coordinate system fixed in the body. Let's say symmetry axis is z axis. This axis symmetry axis we take z axis. That means I1 is equal to I2 what we have. So on three Euler angles phi theta psi and theta gives the inclination of the z axis according to that from the vertical second rotation theta with z axis here actually vertical means xyz then in the second rotation we rotate through theta first is phi then last one is psi okay and this is our picture Euler's angle if you compare the distance of center of gravity from the fixed point will be L let this is the fixed point and center of gravity distance is L. So what is the vertical distance? This distance will how much? Hello? If this is L, okay. Then what is the distance? This angle is theta. Actually this distance. So what is this distance? This to this. Hello, angle theta, this is L. The distance will be
L.
L. No, this is L. From here, okay. I am giving you another color. You can see. This distance is L. Okay, this one L. Or what is this distance? Vertical distance from this point to this. Here to here. This is L. This is theta. So it will be L cos theta.
Yes, L cos theta. Yes, sir. Yes.
And its mass is mg, mass and gravity. So what is the potential energy? mgl cos theta.
Cos theta.
Okay. mgl cos theta. Okay. Now this is the theta phi psi. Euler angles. You can compare this with Euler angles. Now psi dot rotation of the top about his own figure axis. Phi dot precession of rotation of figure axis about vertical theta dot nutation of bobbing of the down figure axis. Here condition is the three velocities. Condition is psi dot greater than theta dot greater than phi dot. Rotation about one axis, this rotation is greater than rotation about vertical, that greater the up down motion, nutation bobbing up and down. Bobbing up and down is called nutation. Means you see that bob is motion is up down motion. Another is rotation about one axis, and precession. Precession means it is tilt motion. It is moved like this. Okay, like an axis. If you see in here, it move like another here. Okay, this motion. It is some type of circular motion. We make an axis that is known as precession. For the symmetric top, we assume I1 is equal to I2 since z-axis symmetry of z-axis. So Euler's equation becomes like this. Third term vanishes. These two. So Euler's equation may not provide most useful description of symmetric top. Here we use Lagrangian procedure. Okay. For Lagrangian procedure, we need kinetic energy and potential energy. We know kinetic energy half I1 omega 1 square plus half I2 omega 2 square. But I1 is equal to I2, so I can take I1 common and this. Now, component of angular velocity in this omega 1, omega 2, omega 3, which actually you can calculate this using the rotation formula, what we discussed in case of Coriolis effect. Using that, you get this type of omega 1 is this, omega 2 is this, and omega 3 is this. You have to get this. If you are interested, I am also providing the slide. Please 1 minute, 1 minute. Hello? Hello? Okay. Oh. I'm ରୋଲ ବୋଧେ 5 7 କଣ ଏମିତି 9 19 ଟା ଏମିତି ହଁ ସେ ଜାଣିନି ତ ଫୋନ ଯାଇଥିଲେ ମ୍ୟାଡମ କରୁଥିଲେ ତ ମ୍ୟାଡମ ତମକୁ ଫୋନ କରୁଥିଲେ ତାର ହେଇଛି ଲିଷ୍ଟଟା ସବୁ ସାର୍ ସାଇନମେଣ୍ଟ ଦେଇଥିଲେ ତ ଅପଲୋଡ କରିବାକୁ ମୁଁ ଜାଣିନି ସାର୍ ଥିଲେ ନା ଯେତେବେଳେ ମୁଁ ସେ ମୋ ସେ ବିଷୟରେ ଜାଣିନି हाँ साथ है जी साथ क्लियर साथ है हाँ 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 तक क्लियर सर व्हाट्सएप को सिंपल इतना दिना नो व्हाट्सएप पढ़ते आप लोग को समझा पाऊँ हेलो ओके हेलो am I audible hello
Yes, sir.
okay
Yes, sir.
you can also derive this formula they are available in any book where rate of change of vector is given if possible, I also provide that material. Mm. So these are the omega value of omega 1, omega 2, omega 3 in terms of this velocity component theta dot, phi dot, and psi dot. So using these in place of omega 1, omega 2, and omega 3, we got this expression. That here actually I1 is equal to I2. You know I symmetric about z axis, so I1 is equal to I2. Okay, and solving these equations, you can get okay. Okay. Square it a plus b whole square, you know a square plus b square plus 2ab, here a square plus b square minus 2ab, and this actually this product plus 2ab minus 2ab cancel, same thing. So we have only phi dot square sin square theta sin square phi plus phi dot square sin square theta cos square psi plus theta dot square sin square psi plus here there is a theta dot square cos square psi and a third term. And this, if you take phi dot square sin square theta common, then it is sin square psi plus cos square psi, which is 1. If theta dot square common, sin square psi plus cos square 1. So we got this and this one. Okay, is it okay? Hello? Okay, can you get this equation too? Only you have to remember these three, or you can derive it, which is slightly lengthy. But using this, you can get the equation 2. Okay, is there a problem, or you can get equation 2? Hello? Is it clear? Hello?
Yes, sir.
Okay. Then it is kinetic potential energy, what we already see, it is mgl cos theta. So Lagrangian will be T minus V. T minus V means T and minus V. Using this Lagrangian, you can get equation of motion. Okay. But before derive exact equation of motion, we can predict about this motion from the constants of motion. We know if a coordinate is cyclic, then corresponding momentum is a constant. Here you see cyclic mean does not appear in the Lagrangian. Tell me which coordinate is cyclic here? Here actually we use three coordinates. Okay. Phi, theta, psi. Tell me which was absent here. See equation 4. Hello, equation 4 is visible? Hello?
Yes, sir.
Tell me which one is cyclic mean absent? Phi, theta, psi. Among which one is absent? Not dot. Phi, theta, psi. Tell me. Theta present.
Yes.
Phi and psi both are absent. That means its corresponding momentum are constant. Okay.
Yes, sir.
So psi, we can calculate P is equal to del L by del Q dot. So del L by del psi dot. Taking derivative with respect to psi dot, we found this I3 phi dot cos theta plus psi dot. Okay, which is a constant. But this is omega 3. I3 omega 3, we can say it is a constant, means I1 into A. Similarly, P phi, it is another constant, like I1 B. But okay, but P theta is not constant. These are the constant of motion. Also, we know that Hamiltonian or total energy is equal to T plus V, and total energy will Hamiltonian for a conservative system. If the system is conservative, then Hamiltonian is equal to total energy T plus V. T plus V, and V is mgl cos theta. T is this one, two terms. So we get E, P phi, P psi, and E is a constant. For a conservation, E is a constant. These are the three constants. Okay. Slightly rearranging this constant, we can say I3 omega 3 is equal to I1A, but it equal to I3 psi dot plus I3 phi dot cos theta. So I3 psi dot is equal to I1A minus I3 phi dot cos theta. The above result can substitute equation 6. Putting this in equation 6 in place of I3 psi dot. Okay. We get this expression I3 psi dot putting. We get this expression which is further simplified. I1 psi square theta plus I1A cos theta is equal to I1B. Because these two are cancelled. So phi dot will be found as B minus A cos theta by sin square theta. Okay. Similarly, substituting you can calculate psi dot. Procedure given I3 psi dot is this from our equation. Then psi dot is equal to I3 using the value of phi dot. We can write psi dot is equal to this one. Okay. Then we can also define another quantity E minus I3 omega square 3 square by 2 is a constant because the energy is equal to this constant. So putting the value of phi dot and psi dot, we know using the value we found this term and simplifying simple mathematics we get this relation mgl cos theta, which we can take another constant of motion E prime. So this is the effective E prime. It is actually kinetic energy half mv square or rotating body half I1 theta dot square. So rest must be potential energy, effective potential energy V prime theta. This is mgl cos theta plus this. Okay. So now we can define some constants. Normalized constant alpha is this, beta is this, a, b. Then this we can derive this equation. Substituting that we get this equation sin square theta dot square alpha beta when a bi cos square theta. This is only an expression in terms of variables. Why use this variable? Because now we can reduce this equation. If you put u is equal to cos theta, this whole equation u dot then minus sin theta theta dot, putting that you find u dot square 1 minus u square alpha minus beta u by b minus a u dot square. Which can be reduced immediately to a quadrature. Means what is u dot? U dot is root over of this 1 minus u square alpha minus beta a u square. U dot means du by dt is this. So dt is equal to du by this. T is equal to integration of du by this. Actually this root over determines all of the motion. Okay. Because you know u dot square. From this u dot square is equal to 1 minus u square alpha minus beta u square. If you open this, okay. If you open this product will be 1 alpha minus alpha u square multiply 1 with this, then u square 1 alpha minus beta u plus minus u alpha u square plus beta u cube. So highest power will be beta u cube. Then alpha u square here from the whole square a square u square alpha plus a square u square. And u here beta u 1 another minus or minus plus 2 bab u 2ab minus beta u. Then last one is b square. Here is alpha minus b square. So this equation is nothing. So you can say the highest power will be 3. If beta is equal to 0, then it becomes a quadratic equation. Otherwise, it highest power is 3. And for gyroscope, the center of mass is the fixed point. Center of mass fixed point, if you take that, actually beta becomes 0. And if beta is equal to 0, and this quadratic equation, beta is equal to 2 mgl by I1. L is the distance between center of mass and a fixed point. If center of mass is fixed point, then L is equal to 0. So beta is equal to 0. So this term vanishes. We have a quadratic equation for a gyroscope. Okay. And to understand, you can solve this quadratic equation. And this is this observation what you find. For large u, beta u is dominant. Okay. So always positive constant. So you write, if we have two values, one positive and one negative, then actually root lies between them. 0 of that is lies between them. From this equation you can predict that uh, for physical constant u must satisfy value -1 to +1, because why? U is what? Our substitution u is equal to cos theta. You know cos theta maximum value, where we put u. Cos theta maximum value is +1 and minimum value is -1, and always cos theta lies between -1 to +1. So you can say u always lies between -1 to +1. Okay, so u lies between -1 to +1. So figures u greater than 0. Again, for large u, dominant term is beta uq. If u is large, then uq will be more larger. So beta uq will be dominant term. So beta is always positive. So beta uq is positive or negative depending on the value of u. If u +1, beta uq positive. If -1, beta uq negative. If u ±1 putting value, you get here +-1 means square u square 1 u1, putting this u value, it is nothing but plus minus minus b minus a whole square or minus b plus a whole square, the two roots for u +-1. So here plot is given. So since 1 is minus, 1 is plus, so there must be a root lies between minus and plus. If minus and plus, 0 must be like 0 is the root inside it. Okay. So this is actually that picture. One root must lies between minus and plus. Besides this, you can also predict this motion just like this. The motion of a heavy symmetrical top in 3 cases, but actual motion, what is it? Nutation, precession, and rotation. Rotation means motion about one axis. So top is rotating about one axis. Precession means it rotates about vertical, just tilting motion. You see sometimes that child stop, rotate in a tilting way, moving, making some axis vertical as axis. That is precession. Another is nutation, motion up down motion. That tip, top point, this point, tip is moving like this up down. That is called nutation. Okay, these are 3 type of motions found in case of a top. Okay. Hello. Is it clear?
Yes,
Hello?
sir.
Okay. So okay, I think I will stop here. And then tomorrow is the last class where we discuss some things left from unit 2 and 3. This is the rigid bodies block 4 or unit 4 of the. It is all covered. Something left from 2 and 3, but we'll discuss in the tomorrow, which is the last class. Okay. Okay. So thank you.